The Student Space Programs Lab at Penn State is proud to present LuCID, the Lunar Construction Inflatable Dome system. It is a groundbreaking solution in additive manufacturing on the lunar surface. LuCID is an inflatable dome that, once erected on a prepared site, can create suitable conditions to print concrete. It can also regulate its own environment, mainly its temperature and humidity, to provide ideal printing conditions on the moon.
LuCID features a multi-layer skin design that enables us to establish a 0.6 atmospheric pressure inside of the dome against a hard vacuum outside of the dome. The multi-layer skin design also features insulation to protect equipment on the inside of the dome from the extreme temperatures on the lunar surface.
The key components for choosing our materials is lightweight, flexibility, and strength. Nomex is our innermost layer, which is puncture and fire resistant. LuCID's bladder layer will contain the innermost atmosphere with cambithrum and Kevlar felt layer.
To verify LuCID's capabilities, 3 metrics will be vigorously tested. The system's ability to fully deploy and self-inflate, its ability to maintain the proper conditions for construction, and the stress capabilities of the anchoring system.
These tests shall be conducted at Penn State's Space Propulsion and Environments Lab. This lab features an extra-large vacuum chamber that is currently used for testing nanosatellites.
The LuCID dome's primary method of sealing will be a detachable base design. This base will act as both a platform for any construction done within the dome and will allow LuCID to create an airtight seal. After construction is completed, the base will be left at the site and the dome will be relocated. An alternative method could be to use a baseless design. By removing the disposable base, waste produced by LuCID could be reduced. This poses its own issues though, as creating a seal with a regolith in its natural state is nearly impossible.
LuCID is designed for compatibility with other NASA systems in the roster. For example, the dome's foundation will be built with Razor in mind, in a way that it can excavate enough lunar regoliths to help prepare the site for dome deployment. Additionally, the dome can also be maneuvered using a small crane like the LSMS or the LSMS-H.
One of the biggest challenges that the Artemis mission must address is the establishment of resilient lunar infrastructure to enable lunar exploration missions. A basic infrastructure is necessary and crucial for sustaining and expanding lunar exploration missions. However, moving materials from the Earth to the Moon is an extremely costly endeavor. It costs approximately $1.2 million per kilogram to move material from the Earth's atmosphere to the lunar surface.
This high cost makes sending traditional building materials or prefabricated structures more money than it is worth. By allowing for buildings to be created on the Moon, LuCID addresses one of Artemis's biggest roadblocks.
In conclusion, LuCID is an end-to-end system aimed at supporting NASA's long-term lunar exploration missions in the Artemis program and beyond. We believe our cutting-edge research facilities and the expertise brought to us by our faculty advisors in Dr. Baleen and Dr. Linska make our team of 14 undergraduate students a very solid candidate to select. We are very excited to explore more about this project in the Big Idea 2024 Challenge.